All right, so today we are talking about the law of sines. There's two versions, unlike yesterday, we had three versions of the law of cosines. And basically, this is an extended proportion, like we had in our similar triangles, and it takes the sine of the angle and puts it over the length of the side opposite that angle. And we can put the sines of the angles in the numerator and the side lengths in the denominator, or we know the properties of proportions as we can switch those two, numerator and denominator, and still have a proportion. All right, so our strategy for these problems is going to be to sketch and label the triangle like yesterday, but here we're going to be looking for an angle side pair, and we're going to use that angle side pair to write two ratios for the missing components using the law of sines, and then we'll solve that proportion. So we can be given different components. Here we're given two angles and a non-included side. That means the side that we're given is not in between the measure of the two angles that we are provided. We find our match. We write 5 is to the sine of 63 as 8 is to the sine of 46. And then we repeat it. 5 is to the sine of 63 as b is to the sine of 71. And I get that 71 by using the fact that the angles of a triangle are supplementary. And then we solve our ratios for A and B, grab our calculator, and we get 4.0 inches and 5.3 inches. And our quick check to make sure we're thinking about things correctly and setting up the proportions correctly is that we make sure that the lengths of the sides and the angles correspond to each other. And by saying that, I mean the smallest angle has to be opposite the shortest side. The largest or longest side has to be across from the largest angle. Okay, again, we're given two angles and a side, but this time we have the included side, the side sandwich. We make our match. Our match here is going to be this angle with this side. So I write the sine of 96.5 is to 76 as the sine of 50 is to A. 76 is to the sine of 96.5 as the length of side C is to the sine of 33.5. And then I solve each of these for A and C, grab my calculator, round to the nearest tenth, and put my units on there. Now we're going to enter into our third case. Here we're provided different information. It was two angles and a side on the previous page. Now we have two sides and an angle. This is considered the ambiguous case. Ambiguous means we're not sure if we're going to have no solution, one solution, like the first two we did, or possibly two triangles that we can create with the information that we're given. And we'll do the one solution first. So here I've got my match of my side opposite and my angle. So I use that to start my proportions. And then I have sine of B is to 62. That's the one that's got the information I can use. I have to use the inverse sine to get the angle measure. Now, because this is the ambiguous case, I need to do some math to see. I already know I have a solution, but is this just one of two possible solutions? So to determine that, we take and find the supplement for this angle. And that's easily done by taking 180 minus that angle measure. Then we take that obtuse partner, the supplement to that acute angle, and add to the angle that we were provided in the problem. And now I get something that's greater than 180 degrees. And I'm like, no way. This is the one and only solution. So then we figure out the remainder by taking and finding angle C, which is 105.5, and then we make a ratio with that. and we solve that ratio. All right, so back to our law of sines. So I'm not sure exactly where we left off. I think we left off here. And then we started talking about the ambiguous case, and how we decide is we get the supplement for our original angle measure. And if it equals or exceeds 180, then we know this is our one and only solution. The second one here, we get the 47.6, but when I find its supplement of a 148.5, and I add that to the 40 degrees that I had here, we do not exceed 180. We keep it we get 172, which is less than 180. So I have a second solution. The second solution is B is now this obtuse angle of 132.4, making this angle 7.6. And I set up my ratios and solve for side C in both of these triangles. Now, the last one we're looking at is a no solution. We label the triangle, and we find our match, and we set up our ratio. We solve. When we put it into the calculator, it gives us an error. It might say domain error. And it's an error because, like what we talked about in class, the sine ratio is limited to a maximum value of 1, which means we're never going to have an angle that produces a sine ratio greater than 1. And this ratio is greater than 1. It's 1.3.